are we going to do this? It's very simple. We divide the shape into simple shapes, known shapes. So basically, look, we divide it into three parts. This is my rectangle here. That's a triangle, and this is my square. So I know the formula for the centroid of each component. So basically, that's my reference. I will take my reference axis. That's X here, and that's your Y here. And then you can, knowing the formula for the center of each shape, you go for shape 1, that's the shape. That's shape 1. That's the area for shape 1. That's the area for the triangle, and that's the area for the square. Once you know this, and the centroid of shape 1, we know it's half width, half height. The centroid for object 2 is 1/3. Remember, 1/3, 1/3 height and base. And for the square, we know it's half width, half base. And the distance for each along the y from the y-axis, and the distance from your x-axis. You can find the distance of centroid of each component from the reference line very easily. And then you do this, sum it up, and then you will get your axis. So in simple words, I've got a table here. Come on, where's my table? Yeah, that's the table. I'm summing them up here. Area into its x distance. That's basically area of this one. So that's area here multiplied by this distance, where the distance that's here. I've got the area multiplied by this distance. I've got the area multiplied by this distance. And then same I do for the y. And then in simple words, I sum them up. There's the summation sign for this one. I'm summing them up for x and also for y. And then I'll divide it with the total area. Sorry. This is the total area of this shape. 18 plus 4.5 plus 9, that gives me this. That is this point here. And then I divide it and get my centroid out. Is that clear to everyone?
Yes, sir.
Yes, sir.
So it's relatively very simple. Remember, you want to find the centroid of any shape, then you need to, and if it's homogeneous, the density is uniform throughout the shape, then your centroid, and it's more like a 2D, then your centroid, and say your center of mass and weight will be the same. Now to find the centroid or complex shape, remember you divide it into known shapes like triangles, square, rectangle, your circle, all those known shapes. So you find the centroid of each individual shape, and then you use this formula to find, the x, and this formula to find the y distance from the reference. So that will give you the centroid. Okay. Is that clear to everyone? Anything not clear yet?
Sir, do the centroid and center of mass and center of gravity in two-dimensional uniform gravitational field.
Yes, it will be the same.
Okay.
Yeah, it will be the same. Centroid, the center of area, center of mass, center of weight for 2D uniform of homogeneous material. Having same density, yes, it would be the same.
And sir, you told us about centroid of the body existing outside of the body. What was that case?
Yes, that's this one. That's an object made of, it's a steel plate, okay? So its center of mass, centroid will be somewhere here. You agree?
Yes, sir.
That's outside the body basically. Same thing here. I've got a disc. That's a circular disc. It's a donut. So it's made of steel. It's a donut. Its center of mass and everything would be at the center. Am I right?
Yes.
Any other question? Chairman, can anyone remind me when is your exam? So it's on
Sir,
20. It's on 28.
28.
28.
Yes, sir.
Okay. 28. I've got only a few examples left. Soon I'll stop here. But then there won't be anything to teach. Okay, gentlemen, I'll stop here. Let me take the attendance. Give me a second. Okay, gentlemen, so I'll stop here and I'll see you tomorrow then. We'll do one example tomorrow. So we'll linger on till the exam date gets closer. Okay?
Yes, sir, I had a question.
Yes, please.
Sir, I just want to ask that using the center of mass, basically we determine where the mass of the body is most concentrated at. Using the center of mass, that's what we determine. But using the centroid location, what does it exactly tell us about a certain property
Basically,
of?
it's the point where you can balance the whole object.
All right, sir.
It's the point you can balance the whole object.
Okay, sir.
Okay?
Yes, sir. Thank you.
Excuse me, sir.
Yes?
Sir, if we change the orientation of the object, then what would happen?
You can change the orientation of the object.
Yes, sir. Like we rotate it.
You can rotate it, so but you need to get the axis. Look, if you rotate this, come on, wait. If you rotate this object something like this, oh, come on. Okay, you rotated it, and this is your axis. You can split, sorry, you can still split it. You can find the points, am I right? And you can get your distance out then.
Yes, sir.
Is that clear?
Yes, sir. Sir, but would the center of gravity and mass change, and the
No,
centroid
no,
would
no,
remain
no,
same?
no. No, it won't.
So the center of mass and the center of gravity will always change when the gravitational field will not be uniform.
Yes,
That case only.
yes, yes, yes,
Okay.
yes, you're right. Well, gravitation field is basically the pull of the earth. So if I've got an object, let me show. That's the object on ground. Sorry. That's an object on ground. That's on ground, on Earth, and that's the point here. Oh, come on, that's the point here. So it's my center of mass and center of gravity. Both. I bring another planet here. I bring another planet, okay? Jupiter or some other planet. And my center of gravity may shift is here because it's the attraction, remember? Is the attraction force. But my center of mass will never change. If I take this object to space, deep space, where there's no gravitational force, my center of gravity has disappeared. There's no center of gravity in deep space. I will only have the center of mass. Is that clear?